Okay, everybody. If you look at this question here, first question you cannot answer because I haven't taught you anything about refraction yet. So you're actually supposed to skip this. Then after that, this next question here, you are starting to be able to do it lah, because the next information here is that you have the velocity, you have the frequency, and you're asked to determine the wavelength. Very straightforward. You're supposed to use your V equals to F lambda, and your lambda here will be how much, Hayden?
Uh, is zero, wait, 0.4 meter.
0.4 meters, right? Then from here, they say that the time elapsed before compression A reaches the barrier. Compression A reached the barrier here. How long did it take? Ethan, what was your answer?
0.0059 second.
0.0059 seconds. How do you get that?
Uh, the wavelength times 5.
Times 5? Okay, so this is the next thing I want to teach you. So you calculated the wavelength was 0.4 right here, right? I said for wavelength, we always think about it as soon as it starts repeating itself. Even if you don't know what a compression and refraction is, right? The wavelength is as soon as it starts repeating itself. You are thinking that here to here one wavelength, second wavelength, third wavelength, fourth wavelength, and fifth wavelength, right? But if you think about it in terms of our basic understanding, this is compression to refraction. It's not repeating itself yet. If anything, it should be compression, refraction, then compression. This is actually one wavelength, which means to say this is the second wavelength, and this is half the wavelength, which is 0.2. Can you see this? Can you do this calculation again and tell me what's your answer? Astin, did you get this one correct? What's your answer?
I got wait, this is the time. I got 1/850 seconds.
No fractions. Give me answer in decimal place.
I just get like a big number.
Big number. 1 over a big number should be a very small number. I think you're using the wrong formula. What formula do you use, by the way?
Time equals distance over speed.
Oh, yeah, distance over speed. Yeah, so you're supposed to use a distance of 1 over your speed, which was why 850? Your speed is 340, right? 850 is frequency, bro. Then you'll get the right answer already.
Why distance is 1?
Because there's 2.5 waves here.
Oh, but for question B2, if we count like the wavelength, like 0.4 times 0.4 times 0.32, is it correct?
Times. Why times?
Plus.
Oh, plus, yeah. It's going to be 1. These 3 plus together is 1.
Oh, so if they ask for the time, we use distance over second.
Yeah. Distance over speed.
Okay.
Correct, guys. Well, how much do you get for your time? Do you all get time as 2.9 times 10 to the power of -3 seconds? Do you all get this for a final calculation? Anyone cannot get this? Please let me know now if you cannot get it. Anyways. Okay, yeah. Then after that, they ask you to draw the shape and position after A reaches the barrier, right? Guys, first question, will this be high diffraction or low diffraction? Jolie, what do you think? Will this be high diffraction or will this be low diffraction?
High diffraction.
Good, because the wavelength is larger than the... How come it's high diffraction? What makes it high diffraction?
Thing is bigger than the gap.
Very good, because the wavelength is larger than the gap. So means to say you're supposed to draw... You're just expected to draw 2 here, right? So you're supposed to draw 1, then your second one 2, making sure that your wavelength before and after stays the same, because diffraction does not change your wavelength, guys. Then after that, this next part here, state the sound wave can also travel in water. State how sound wave in water compares to that of air. Ethan, will the sound wave be faster or slower in water, and why?
Should be faster.
Very good. Sound wave will be faster in water. How come?
Because like more particles are closer together.
Very good, because the sound wave depends on vibration of particles, right? In this case here, the water particles are closer together. That's why it will travel faster. Faster. Keyword is faster, guys. Sound wave travels faster in water. Please write the full statement down when you answer, because you'll need it in your exam. Okay, moving on. You can skip this once again because you haven't learned anything about it. Figure 6.1 shows two rare fractions A, B, blah, 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 determine the wavelength here, given the A and B is 0.76. Hayden, how much is the wavelength?
I'm not sure.
How do I use the 0.76? How do I use the 0.76?
The 0.76 is the lambda.
No. 0.76 is this whole thing here.
Oh,
Rare
uh,
fraction, rare fraction. This is one wavelength.
divide by 4.
Good. You're supposed to just take 0.76 divided by 4, and you'll get your answer already, which is 0.19 meters. Can Then once again, the time taken. Aston, what's your time taken here?
Time taken is, wait,
For A to reach B, so it's like this is the distance it traveled. Similar question to the one on top just now. How do I do it?
my answer is 1.282 times the, what's it, 10 to the power 4.
10 to the power of 4. 4 times 10 to the power of 4.
Yeah.
That seems like a really big number for such a short distance. 10 to the power of 4, you're essentially like 12,820 seconds already. Oh. This is, how much is that? In terms of minutes, 12,820 divided by 16. That's 200 over minutes, and that's almost 10 days for 0.19 meter. Something is wrong somewhere. What formula do you use, Aston?
The time equals distance over speed.
Okay, same thing again. Time equals to distance over speed. How much is your distance?
I used the 0.76.
Good, this is correct because the distance is 0.76 this time. What about your speed? How do you get your speed?
Uh, I times the frequency with the distance.
What distance? Like 7800 multiplied by 0.76.
Yeah.
But 0.76 is not the wavelength. 0.76 is this whole thing. How much is the wavelength?
0.19.
So it should not be 0.76, right? It should be times 0.19, right? If you times this, how much is the speed?
1482.
1482. With this, you should be able to find it here, right? 1482. Press your calculator again and find out how much is the time.
It's 5.128 to the power of 10. No, to times 10 to the power 4.
Times 10 to the power of 4. 4?
Oh,
Are you sure?
yeah, I put that number.
First and foremost, even if I take 1 divided by 1000, it'll be an extremely small number already. Right now, I have an even smaller number and an even bigger number on top. Of how can it be times 10 to the power of 4? Times 10 to the power of 4 is going to be like 51,000, bro. Are you sure you pressed the right calculator?
I,
You're supposed to get times 10 to the power of -4, bro. What did you press wrong?
oh, I left out the negative, sorry. Yeah.
As in... Yeah, it's supposed to be -4. Okay, good. Then moving on. Jolie, what happens to the frequency?
Uh, uh, Stay the same.
Yeah, it will stay the same. For anything related to frequency, it will mostly stay the same unless given a different scenario. What about the wavelength? When the speed of sound is greater, Eason, what do you think will happen to the wavelength?
Decreases.
Decreases, ah. How come?
Then does it increase?
Okay, it does increase, but how come?
Oh, because speed is greater, so the distance is also going to be greater.
Not exactly wrong, but you're actually supposed to relate to V equals to F lambda, my friends. If this stays the same, this increase, this thing for sure increase, right? I give you a numerical value. If frequency was 10 and the speed increases from 2 to 4, and obviously the wavelength would be 0.2 to 0.4, right? The increase in velocity from 2 to 4 will cause the wavelength to increase from 0.2 to 0.4. You understand?
Yeah.
Okay. Anyways, they ask you to sketch the position of the refractions. This is sound wave, right? Will the sound wave travel faster in water or wood, Hayden?
Uh, wood.
Good. So how the wavelengths how are the wavefronts gonna look like when it reaches wood? Will they lead forward or will they lag behind?
Lead forward.
Very good. They'll lead forward. So you just draw one, then make sure the rest of it is parallel with the first one. Then you're good to go already. Okay,
For
gentlemen.
question C2,
Hmm.
the
Uh,
water into the wood, does it represent like the deep water to the shallow water?
no, it will be shallow water to deep water because the speed is greater.
Oh, okay.
Right. Shallow is speed slow ma, deep speed fast ma. So here to here is increase in velocity, right? Hey, Wood, anyone got any questions? Oh, that's the last question. Yay. Anyone got any questions? No? Good to go? Okay, if you're all good to go, then let's go to the next chapter. Estienne, I sent you the file already, right? Oh, okay. Okay, let's move on to the next chapter here. I think I'm almost caught up to most of your school syllabus already. Shit, I ask this almost every week, but let me ask again. Uh, Hayden, which chapter are you in school right now?
Light waves.
Light waves, ah.
Yeah.
So here already, huh?
Yeah.
Then we caught up already, ah.
Yeah.
Good. Then now we can slow it down a little bit, but I still want to try to complete the syllabus with you guys preferably before January. So we have at least 3 solid months, February, March, April. Yeah, February, March, April to do past year papers together because God knows just the theory is not going to help anyone at all.
Is it possible to finish it like around December? So like because my mock is at January.
Oh, I'll try to cover until your mocks are. I don't think your school will finish the syllabus though by December. I'll cover until at least your mock chapters. Then you'll be yeah, you can start actually attempting like some past year papers already because you'll need to exercise for your mocks. Anyways, moving on to this part here. Okay, guys, so right now we talk about light waves. Light waves is a little bit different from water waves in the sense that water wave can go through three phenomena, right? These three phenomena are basically your reflection, refraction, and also diffraction, right? For light wave, it'll only go through these two. I mean, in your syllabus, at least. Actually, light can go through diffraction as well, but it's not covered in your syllabus, so you can ignore it. Okay? For light, only these two. Okay? Starting off with reflection once again, it is relatively straightforward. I just want you guys to focus on two specific things. First and foremost, if you look at this image here, this is basically imagine this is you and this is a mirror. When you stand in front of the mirror here, what's going to happen is you'll see yourself exactly opposite of the mirror, right? And you'll notice that however far you stand from the mirror, it seems as though your image is appearing however far from the mirror inside as well. Okay. The next thing you want to know is basically in your syllabus, whenever they talk about light waves and reflection, right, they will usually ask you to draw the light ray diagram, as you can see here. The light that hits the mirror will be reflected back, the light that hits the mirror will be reflected back, and the light that hits the mirror will be reflected back, as you can see all this here. Okay. So because the real light is actually reflected out of the mirror, it seems as though, right, the virtual light goes inwards, guys. I want to repeat this again. Real light, which is represented by this solid line, actually reflects away from the mirror. So whatever that you see in the mirror is known as a virtual light. It's not real. It seems like the light is going into the mirror only. Okay. So in your exam, of course, they will usually not ask you to draw so many. They will usually ask you to draw two. The question will be something like this, okay? Okay, right now I've got a mirror here, and then I'm standing right in front of the mirror, hailing Hitler. Any, any Jews? Anyways, just for reference, right? Let's say this guy is hailing Hitler, right? So then they'll ask you to say something like, oh, draw two light rays to locate where the image is. I like how everyone started a while when I said hail Hitler. I like that. I hope I captured that on recording. But anyways, so they'll ask you to draw a light ray to locate where the image is, right? So imagine this is the point of interest. You'll actually need to draw two light rays. Number one that goes into the mirror, reflect, and number two that goes through into the mirror and reflect. Of course, when you draw, you cannot just simply draw. You have to draw the normal line, measure this angle, measure another angle again, and then reflect. Draw one line, draw a normal, measure this angle, measure another angle again, and reflect. Right. Then once you have this, right, your virtual light will go in and look something like this. Okay, it'll go in and look something like this. As soon as the lines intersect, this is where your image will be formed. So this guy here will be hailing Hitler inside the mirror as well. But you'll notice one thing whenever you stand in front of the mirror, this guy that is raising up his left hand will have seen someone inside that is raising up his right hand. Do you know what's this phenomena called? When left becomes right. Do you know what this phenomena is called? It's called anti-Hitler. No, I'm joking. It's called laterally inverted. Laterally inverted. It's called laterally inverted, guys. Okay. Whenever you see the word inverted, usually it means to say it's upside down, right? Laterally inverted is left side right. Okay. I repeat again, inverted is upside down. Right, laterally inverted is left side right. Okay, this is a phenomenon, Okay, so with this here, you have completed your light ray diagram, which is very common in your exam, guys. You need to know how to draw just by basically reflecting the light, reflect light, reflect light, reflect light, and draw the virtual light, draw the virtual light. You will most certainly never be asked to draw 6 light rays as you can see here. Never. Okay, you will be asked to draw 2 light rays as you can see here. And you'll be asked to locate where the image is. Don't worry, later there'll be a question where you can practice to draw. And usually students will get it wrong, but I'll teach you a way later on. But have this in mind, you need to draw 2 light rays. Please refer to this diagram later when you're asked to draw the image from a mirror. Okay, so anyways, image formed from the mirror is always going to be virtual because it is essentially formed by virtual light, right? Then it must be virtual. And must also be laterally inverted. Okay, laterally inverted. And everything else is not important. Law of reflection still plays a role here. Like I said, incident ray, incident angle, normal, then reflected angle, then reflected ray. Okay. Law of reflection states that angle of incidence must be equals to angle of reflection. Nothing much to explain here, so quite straightforward. Read through it yourself. Okay. I do want to talk about refraction of light a little bit before we proceed on. We're going to do quite a few calculations today, guys. So please pay attention. Okay, so for refraction of light, I think the most common scenario is that when you step in front right in front of the swimming pool, right before, what's that term called? Anyways, the swimming pool is right in front of you, lah, right? When you look into the swimming pool, it always seems as though it's much more shallow than it actually is. Why? Is because our brain only perceive light to travel in a straight line. But when light enters from different mediums, in this case here from air, which is one medium, to water, which is the second medium, light actually bends. So in reality, the light actually bends like this. Okay? But our brain has always perceived light to travel in a straight line, so we think that the light is traveling like this here. That's why we always see the swimming pool, the bottom of the swimming pool always seems much more shallow than it actually is because light actually bended, but our brain perceive light in a straight line. This is what actually happens to the light. This is what happens in our heads, basically, right? That's why it's always much more shallow than it actually is. In your exam, they will ask you to draw this as well. Please take a mental image of this picture here, right? Having this will definitely help you draw the diagram much better. But I'm sure most of you guys will forget it by the time we actually reach that question. So once again, please know where to look for. Right? You
I
need
thought the line, the arrow is supposed to go the other way.
like here.
Yeah.
No,
Why?
it's supposed to be because this is how your light is coming into your eye, right?
Oh,
Right, the light is not going like this, right? The light from the fish is coming into your eye like this. Okay. Yes, don't worry. Later, I've mentioned this multiple times to everyone before already. Usually, when it comes to the question, they'll forget again. So we'll just revisit this picture later on when we attempt the questions. Okay, but before that, anyone want to ask me anything with regards to everything I talked about? Okay, good. Next, we talk about refractive index. Refractive index is quite an annoying calculation because there are a few certain rules that students always miss, and thus they will lose their marks in exam. And there are three formulas for refractive index itself. So you actually need to memorize a little bit here. Okay. First and foremost, before we even talk about refractive index, we understand how light works first. Okay. If light enters the medium exactly at 0 degrees, right, that means to say it's parallel against the normal. This is what we call perpendicular against the surface, right? The light is not going to bend. Okay, it will literally just go straight down like this. You can try this later on at home. You just like take your water bottle and then you shine, like not water bottle, like a basin, right? And you shine water that is going to go 90 degrees downwards. Okay, you'll notice that the light does not bend. But any angle besides perpendicular against the surface, the light is going to bend. And here you need to remember whether the light will bend towards the normal or it will bend away from the normal. Anyways, let's draw a little bit, guys. So let's imagine this is a glass block. Okay, this is a glass block. Now, obviously, before the glass is air and air here, okay, like air. Okay. Anyways, so what's gonna happen is any angle besides perpendicular against the surface, right? If it's 90 degrees, the light is not gonna bend. But any angle besides that, the light is going to bend. First and foremost, let's see this scenario here. When light enters from air into glass, as soon as it hits the surface, what you're supposed to do is you're supposed to draw a normal, right? A normal that is directly downwards. And then you're going to ask yourself one thing only. If, let's say, right, light travels from air into glass, will it become faster or will it become slower in glass? What's the answer?
lower.
Slower, good, excellent. It is going to be slower. So if let's say the light did not change in terms of speed, right? The light was supposed to go straight down like this, man. Right. But because right now it is slower, it's slowed down, right? So it will actually bend towards the normal here. You'll see that the light bended towards the normal in the sense that this incident angle and this is the refracted angle. If, let's say, this incident angle is 40 degrees, this refracted angle can never be bigger than 40 degrees or because it bended towards the normal, right? So maybe it will be somewhere around 30 degrees here. Okay? Your incident angle was always be bigger than your refracted angle. Then right now we continue the line lah. Let's imagine this line. Oh, let me use a different color. Let's imagine this line here continue going downwards lah. Then right now it goes from glass into air. Once again, as soon as it hits any surface, I'm expected to draw a normal that is perpendicular against the surface. What do you think will happen? Will it go faster or slower this time when it travels from glass into air?
Faster.
It'll be faster. So originally it's supposed to be one straight line, right? Right now it's faster, what? So it'll bend away from the normal. It'll look something like this. Okay? I want to highlight that this angle here is literally the same angle here because they came from, they'll go in and exit at the same angle, which means to say mathematically, right? This is going to follow your Z rule, right? In terms of mathematics, means to say this is going to be 30 degrees or so. Anyone don't know what I'm talking about so far? This is important. Let's talk about the basic understanding. So in conclusion, here the light will bend towards the normal. Here the light will bend away from the normal. Anyone? Anyone don't know what I'm talking about? Anyone wants me to repeat? Please ask to repeat if you don't understand. You are just going to stack confusion after confusion if you don't ask anything.
So always when light goes through any glass, then it starts to slow down and like bend away from the normal.
Okay, very good question. So light will always bend when it enters from one medium to another. It depends on what's that medium. In this case here, this medium is air to glass, right? So because I know that here the speed is faster, and here the speed is slower. As soon as the speed is slower, usually it will bend towards the normal. But when it goes from glass into air, this speed is higher here. And because of that, I know that the light will bend away from the normal. It depends on the material also. So let's say, for example, a different scenario, I got like glass and then I got like water here. Right. First things first is I need to figure out where is the speed faster, Is it in glass or water? Which in most cases, it'll be water, unless specified differently. Right. So in this scenario, if let's say the glass has a slower speed and water has a higher speed, which means to say it's going to bend away from the normal also. If the light shines here, it will bend away from the normal also. Because it speeds up here. You get what I mean? A different medium. But anyways, you need to figure out which medium travels faster and which medium travels slower. Okay? Got it. Anyone else with any questions? A good 100% absorption. We'll go through the calculation right now. So if you look here, it's literally a summary of what I talked about. It's not less dense, by the way. It's not less dense. It's less dense. Right. When light travels from air, which is less dense, to glass, which is more dense, light will bend towards the normal because it slows down. Right. Whereas when light travels from more dense to less dense medium, the light will bend away from the normal because it speeds up. Okay, gentlemen. Okay. Then now we're going to calculate refractive index. Refractive index, just for a quick introduction you can just look at here. The higher the refractive index, the more the light is going to bend. Imagine I got vacuum, air, water, glass, and diamond here, right? Depending on the refractive index, as I've already arranged them to increasing order, the light is going to bend more and more and more and more and more and more and more. And because of this refractive index of diamond as well, right? You always see that diamond shines from within. A phenomenon known as total internal reflection, which we'll talk about later on. Don't worry, after we're done with the calculation. Total internal reflection occurs when light actually bounces off. Let's imagine today I got a real diamond versus a cheap-ass diamond I bought from Pasar Malam. Okay, this is a shit diamond. Okay, when light enters a real diamond, right, because of its high refractive index, it'll go through total internal reflection and it'll keep bouncing inside internally before it actually shines out. And because of that, when we look at it from our point of view here, it seems like the diamond is shining from within because the light is literally bouncing inside. Whereas a shit diamond from Pasar Malam, the light will enter, bounce one time, maybe two times, then it'll come out already. That's why a fake diamond will always look more dull compared to a real diamond because of total internal reflection. But we'll talk about that later on. There's a page that talks about this later on. Okay, for now, you need to know that the higher the refractive index, the light is going to bend more and more and more and more and more. That's all for now. Anyone want to ask me anything? Okay, good. Moving on. Now we're going to do calculation already. Okay. Guys, let's look at this calculation here. There's two formulas you need to use. A little bit of memory, this one. Right. Refractive index is sin I over sin R, or refractive index is going to be C over V. Okay. How do I use sin I over sin R? How do I use C over V? Let's look back into the whiteboard. Wait. 10K. Wait. Wait. My Zoom is lagging. I can't load my whiteboard. Give me a minute. What? Oh, they asked me to send error right now. Is this gonna force stop? Oh my god. Are you guys still there, by the way? Oh my god. My Zoom is gonna force me to stop the thing. Oh no. That's not good. I'm recording halfway. I need to wait for it to respond. Let's give it a minute. And that's not good. It's lagging these days. My computer seems to be lagging a lot recently. Why? Time for a new computer. Hello? Am I back? Hey. No. Hanging again. Okay, anyways, I was saying just now, right? So there's two formulas, right? N equals to sin I over sin R, and there's N equals to C over V. Okay. Let's imagine today, I've got a class block here. Okay. And then I'm gonna have light traveling in here, and then I got light obviously bending here. Okay. Let's say here is 40 degrees and here is 30 degrees. We go away. Okay, 30 degrees here. So if I'm asked to calculate the refractive index here, it's very straightforward. It's basically using this formula, right? When you in this case here, it'll be sine 40, because 40 is the incident angle, over sine 30, which is going to be the refracted angle. Okay. In this case here, can someone press the calculator? How much is this? Sine 40 over sine 30?
1.29.
1.29. Okay. So right now, once I have the refractive index of this thing, right, I can actually calculate how fast it is going inside also, Because with this second formula here, right, C over V, this is speed of light, which is 3 times 10 to the power of 8 meters per second. Have I introduced this to you guys before? 3 times 10 to the power of 8? No. Okay, now you need to remember that this is a constant number. Another thing to memorize. 3 times 10 to the power of 8. Okay? Speed of light in the medium is going to be 3 times 10, which is this one here, 3 times 10 to the power of 8. Right. With this here, I can calculate. With this here, I can plug this in here and calculate how fast this thing is going also. Right. So essentially, it will be 1.29 is equals to 3 times 10 to the power of 8 divided by my V here. Can someone press how much is V? 3. I'm almost certain this answer is wrong. how can the speed of light in the medium be faster than the speed of light here? How much will the speed of light? Yeah, it should be this, I think. This should be the answer, which is should always be changed in the standard form. Your V is going to be 2.3233 times 10 to the power of 8 meters per second, which means to say this guy here is traveling at 2.33 times 10 to the power of 8 meters per second. And this is how I use these two formulas here. Can I? Anyone want to ask me something? Aston, how come you always press wrong in your calculator? Are you using your brackets or not?
What's N?
Huh? Refractive index. Refractive index is basically how dense the material is.
So N is just trying to find the dense material.
Yeah, basically how much the light is going to bend in the material.
Oh,
I just times the refractive index with the speed of light.
Times broski. It's not supposed to be times, bro. V is supposed to be 3 times 10 to the power of 8 divided by 1.29, my
Oh.
friend. Okay. Okay, everyone understand this calculation? Anyone wants to ask anything? Okay, so this will almost never happen in your exam because it's too straightforward already. If they do give you this, you must thank the Lords above because it's too straightforward already. Usually your question will be something like this instead. Okay, let's imagine right now I have this glass block here, and then I say that this incident angle here is, let's just say 30 degrees. Okay, I want to find out how much this angle will be reflected. Okay, how much will be refracted? I don't know. But I'm given the refractive index right now, n is equals to 1.5. Can all of you guys use the formula n equals to sine I over sine R and calculate me how much this angle will be? I'll give you guys 3 minutes. Please do that right now. Can How much? How much? How much? Everyone, give me an answer. I wonder if everyone got the same answer. Oh, who wrote this? Hmm. How do you write off screen though before I showed it?
Huh? I honestly don't know. I just can write, bro. I was tapping on the screen just now and I suddenly can write.
Huh. Okay. Jolie, Aston. Hey, this is Aston or Eason? This is Aston, right? This one? Eason. Hayden, wait. What's my answer? 20 degrees. Ah, Jolie, I'm surprised. You are the only one who got the right answer.
But that's because my math is good.
It's not mathematics, this one is understanding. But very good. Congratulations. I'm proud of you. Very good. Guys, this one has nothing to do with mathematics because it's a simple formula, right? What most of you guys did was you found out that, you probably did, you, you, right? You probably did something like this. You found out this formula and then you this. And because I told you it's the incident angle, right? You probably did something like this, right? 1.5 equals to sine 30 over sine R, right? And then most of you guys calculated your R as 19 point something, depending on how much decimal places you got. But I ask you one thing, guys, if this is glass, right? And this is air, isn't the angle supposed to bend away? And if it's supposed to bend away, shouldn't the angle be, it should not be anything less than 30 degrees, right? So for this to be 90 degrees, 19 degrees, it's basically saying that the light bended towards the normal already, which is not going to be the case, right? This is how you will lose marks in the exam. And this is a typical way the IGCSE like to make you guys lose marks also. You're supposed to understand that because the light is supposed to bend away, whenever you're using this formula here, you're supposed to use incident angle for anything that is air and refracted angle for anything that is glass. Because if you think about it, right, even if I say that this is your incident angle, when you look at it from a bigger picture, this should be my incident angle, right? Because even though what I give you here right now is 30 degrees, by right, I'm looking for this one. Can you see? Can you guys correlate? Just now, that question, I'm giving you this half. But if we look at the big picture here, just now I said that this angle and this angle should be equals to this angle, right? And this 30 degrees should be this angle here, right? Can you guys see? Huh? So in other words, you're not supposed to use this. This is going to be wrong. You're supposed to use. Wait. You're supposed to use 1.5 equals to sine I because we're looking for the one in air over sine 30. From here, you should get an answer. And if Jolie's calculation is correct, you should get somewhere around 48.6 degrees. Can you guys do your calculation again, just to double confirm if his calculation is correct? Can I? Guys, anyone cannot get 48.6 degrees? Anyone don't know how to get, please let me know now also. I'll show you how to do it in the calculator. Oh. Okay, so anyways, from here, you're supposed to do it step by step. I'm going to move this over first. It'll be 1.5 times sine 30, which you press in your calculator is going to be equals to sine I, right? Then once I have this number here, I need to press in my calculator shift, then sine. From which you'll see in the calculator, it will look something like sine -1. Then only I press bracket and I'll press the answer button on the calculator and then I'll basically get my answer already. Can you try and do that right now, Aston? Because I need to move this sign over. When I move this sign over, it will become shift sign, which is going to be sine -1, then bracket. You get it? Can get 48.6. Can I? Okay, everyone got it, Jolie, good job. You are the only one who got it correct. Anyways, having said that, guys, I think I'm not going to proceed too far already today. Maybe we'll continue this next week. Guys, can you use the rest of the 15 minutes? Copy everything down. Always write a bracket that this should be the one in air and this should be anything that is not air. Right. Speed of light in vacuum should always be 3 times 10 to the power of 8 meters per second. And yeah, copy everything and then start attempting the 4 questions at the bottom right now. Guys, can do it. Anyone stuck? Is everyone done, by the way? Oh, okay. Guys, I'm going to stop class here today. Please finish up the 4 questions. We'll discuss the answers next week. Then after that, we'll continue with the next part of light, which is going to be total internal reflection, critical angle, and then we're going to do questions together already. Okay, everybody? I'll see you all next week. Goodbye.
Bye.